Hi, in this video I'm going to explain how to get the derivative of a function when the function is an exponential function. So when I say exponential function, that means the function can be like 2 to the x, or the function can be 3 to the x, or any number for the base. Sometimes it can also involve the number e, so in this case I can have like a function e to the x. Not only that, the function can be 2, the base is 2, but the exponent say is 2x. So the exponent is an expression with respect to x. Or say if I have a constant 3 and the 3 is being multiplied to an exponential function e to the 4x. So we will learn how to deal with these functions when it comes to finding the derivative. Okay. So to start with the idea, so if you want to get the derivative of a function, okay, so let's name our function f of x equals c. Now c here can be any number, okay? So like here 3 is as an example of e, or c rather, and then there's a base a. Say it can be e, it can be 2, okay, it can be a 3, then raised to an expression containing x. That can be a simple x, or that can be a 2x, or that can be a 4x. Based on the rule, the derivative of the function is equal to c will remain c, a constant number, and then we copy the function a to the u of x. We take the ln of the base e, the ln of a, base a, not e, base a, and then times, then we multiply this by the derivative of u of x, which can be named as u prime of x. Okay, to give you an example, so let's say our function is f of x equals 3e to the 4x. So f prime of x, by the rule, 3 is still there, so 3, and then so c, the constant 3, and then we simply copy the function, or the e to the 4x, then ln of the base e, so we have e, that's a base e, and then this is multiplied to the derivative of u of x, this is u of x, which is just 4. So to simplify the resulting derivative, ln e is equal to 1, so this is just 1. 3 times 4 is equal to 12, and then we have times e to the 4x. Or in simplest form, this is 12e to the 4x. So that's how you get the derivative of the function. Now, it can be as simple as 2 to the x. So applying the rule, we have f prime of x is equal to, so there's no constant, so we just copy the function, and then so this a of x, remember, then ln of a, so the base is 2, so ln 2, and then times the derivative of the u of x, which is x, so the derivative of x is 1, so times 1. Simplifying this, this is 2x ln 2, and you can even write this as ln 2 times 2 to the x. So that's the derivative of it. Okay, so when you see that the function is in the form of c a to the u of x, we simply apply the rule c, the number, the constant, the function, so times the function, we're not changing anything from a u of x. It is still a u of x. And then we multiply that by the ln of the base, a. Then finally, we multiply it by the derivative of the exponent, u of x, which in symbols, it's u prime of x. Okay? So just for a recap, or final example so that you can get the idea, let's do one more example. So say f of x is equal to, let's put a number. I have 3 times 4 to the 8x. So take note, 3 is not covered by the exponent 8x. 8x is simply the exponent of 4. So if I get the derivative, 3 will not change. So there's a constant c. Then 4 to the 8x, we copy the function. We take the ln of the base, and then we find the derivative of 8x, which is simply 8. And then just simplify. This is 24. That's 3 times 8. And then you have 4 to the 8x. So 8x. And then times ln of 4. And that's the derivative. Okay? One more. Sometimes it can be a sum and difference of expression. Say f of x is equal to, say I have 2e to the 4x plus e to the x plus an e. Now, there is a rule that if you have a function which is composed of about 2 or 3 terms, to get the derivative, you simply get the derivative of each term. So first, we work on 2e to the 4x. So that's 2 function ln of the base, and then times 4. So that's the derivative of 2e to the 4x. And then we move to e to the x, so it's plus derivative of e to the x, so it's e to the x, the function, okay, and then ln of the base e, and then times the derivative of x, which is just 1. And finally, the last term is an e. Now this can be a bit confusing, but e is a constant value, and the derivative of any constant is 0. So this is plus 0. So the next step is we simplify the resulting derivative. So we have, note, ln e is 1. So 4 and 2 becomes 8. Then we copy e to the 4x. Again, ln e is 1. E to the x times 1 is e to the x. Plus 0 is just plus 0, so we don't write plus 0 anymore. So this is the derivative of the function 2e to the 4x plus e to the x plus e. So everything will depend on the rule, okay, for the exponential function. So always keep in mind this rule for exponential functions. Okay, so I hope you understand now how to get the derivative of functions which are exponential functions. Okay, that's it.